So we talk about the insect resistance to pesticide, bacterial resistance to antibiotics, and then artificial selection in dogs breeding and plant cultivation. Let me give you one extra one. Number 4. I call it Extinction of Dinosaurs. Oops, sorry. Extinction of Dinosaurs. And the rise of mammals. Extinction of dinosaurs and the rise of mammals. So it followed the same logic of the insect resistance to pesticide and bacterial resistance to antibiotics. Remember what we learned? Well, you may have learned it in high school or in your previous college education, or even if you haven't learned it, you must have heard about this from mass media. There's originally our world is occupied by dinosaurs, okay, and then somehow an asteroid hit the earth, and then the dust stirred up by the impact of the asteroid rise to the sky, and then it cover up the sunlight. When there's no sunlight, all plants die. When plants die, animal dies. So all the dinosaurs die because of this impact of the asteroid. And then guess what? Although most of the animals die, we call it mass extinction, including dinosaurs, due to this so-called asteroid impact. But some animals survive. What are the animals survive? The animal that had a smaller body size. When they have smaller body size, they don't need that much food, then they can survive. What are those animals? Those are the mammals. So after the gigantic dinosaurs all die off, then a few mammals survive. When mammals survive, and now they do not have the competition with the dinosaur, because all dinosaurs die off, and then now all the food resources on the earth, they are available for the mammals. That's why after the extinction of dinosaur, there is a rise of mammal in the population until nowadays. So this is like the 4th examples of microevolution. Oh well, to reward some of you who watch video, okay, I will test you about this during the exam, because I noticed that many of the students, they do not watch my video, and then it hurt my feeling. So I will put this question: what is the 4th example of microevolution? Then you know that, okay, it's extinction of dinosaur and the rise of mammal, and the rise of mammals. Okay, for those who watch my video, okay, you are lucky. Okay, now we finished microevolution. Let's start with the macroevolution. So macroevolution. So what happened is that the genetic changes caused by microevolution over generations, thousands of generations. Okay, it takes a long time. As I said, that natural selection takes a long time, and so that organisms, they are originally from the same ancestor. From the same ancestor, they will start to so-called diverge and become different species. So we will look at this type of macroevolution. So macroevolution basically is to say that, okay, if all animals, all living organisms on this earth, we all have one common ancestor, but after thousands of years, thousands of generations, okay, the changes in the gene will so-called lead to the development of different species. We'll look at this process now. We call this process macroevolution. So as I said, that we all have a common origin or common ancestor, and then we diverge into different so-called kinds, or you may call it a species, in a vast period of time. Well, it takes 3.5 billion years to do that. Okay, this is the you may call it the tree of life. Literally, you may call it tree of life. So you can see that, okay, most of the general public, they know a little bit about science, but they don't know too much about it. They said, oh, human being, evolution, okay, evolution is not good, it's a bad theory because it says that, human being, we are evolved from monkey. Look at this. All living organisms, including plant, we evolved from one common ancestor. This common ancestor is basically, they are the unicellular organism. It's a one-cell protist. You may call it protist. Unicellular organism. Even dinosaur, but no one said that, human being. No one said that human being evolved from dinosaur. We always have a human being evolved from monkey, but actually it is actually a wrong claim. Human being and monkey, we evolved from other common ancestor. Human being and monkey, or human being and chimpanzee, or human being with other primate, okay, in general, human being with other primate, we can call them cousins. We are cousins. We share the same common ancestor, but don't say that, human being, we evolved from monkey. That is scientifically incorrect. Is that clear? Okay, biological evolution fits into greater evolution of life through chemical evolution, So biological evolution, chemical evolution, and then evolution of the Earth, and then evolution of the solar system, and evolution of the universe. So you can see the development here. Biological, okay, just say bio. Chemical, come from the chemical evolution. Chemical evolution comes from the evolution of our Earth, and then the Earth comes from the evolution of the solar system. Yes, even solar system and our Earth, we have evolution, and the solar system comes from the evolution of the universe. Everything is evolving. So the evolution we talk about like every day is basically only the biological evolution. We have evolution in the universe. So it's like from small. Right now, what we drew in here is like from biological to universe, meaning that from the smallest to the largest. So we will look at all 6 evidence for macroevolution. The first one is, there's a spelling mistake here. A lineage. Lineage, there should be an E here. Sorry about that. I remember I changed this. How come it is still here? Yeah, I remember I changed it. I don't know why it is still here. Fossil record. Fossil record is a very strong evidence for macroevolution. For that, we'll look at two types of evidence: lineage, there's the E, lineage, and transitional. For lineage, we look at the horse. For transitional, we look at we call it primitive bird or the reptilian bird, Archaeopteryx. You may call it dinosaur bird. Okay. Let's take a look. Before we look at the lineage or the transitional, we need to know a little bit about geology. Okay. What we see nowadays, let's say if you go to Grand Canyon, okay, during this long weekend or during the Thanksgiving, well, I guess no American go to Grand Canyon during Thanksgiving. So if you look at Grand Canyon, you can see that Grand Canyon, they have different layers. You can see different layers. The different layers is formed during different time period. I'm not a geologist, okay. Seriously, I'm more a biologist. Well, from the lecture you can tell that my photosynthesis and cellular respiration, you can see the two different clarity. I explain cellular respiration better than I explain photosynthesis. So you can see that, okay, this one Shupei sandstone, what is from 285 million years ago, but the K-bed limestone, they are 250 million years ago. So the time difference is like 35 million years. So different layer, they are formed during different period. What's so important about this? Well, it basically tells the younger rock layer, they're on top, older rock layer, they're at the bottom. Okay, what's the difference? The difference is here. You can see that if we find any fossil from deeper layer, that means those fossil or those animals, they are so-called older in terms of evolution or in terms of development. They are the ancestor of the younger animal that you can find in the upper layer. So usually whatever you find in the upper layers, they are like the descendant of the animal in the lower layers. So due to the different layer of the rock, we can estimate. So this is the first important point. The animal or the fossil that we found from the upper layers, they are usually the descendant of the fossil or animal we found in the bottom layer. Second point is that when we find animal in different layer of the rocks, we can estimate the time that they exist on the earth. This is very straightforward because different layer of the rock, they are formed in different ages. So if we find animal in certain layer, then we can safely assume that, okay, those animal exist in those period, in a specific time period. And number 3, what's the advantage of this one? Well, we can estimate, okay, how much time does it take for evolution to occur. For example, it may take 35 million years for animal in the layer B to evolve into layer F, something like that. So we can estimate the time required for natural selection or the evolution to occur. So fossil record, well, they are fossil record. You can see the continual changes in the population again. It is the changes in the population of a species over time. We'll give you an example of horse, and then there's something called transitional species. That means it is in between. It's like a hybrid or in between two species. But we'll give you an example of Archaeopteryx. Okay, these two tables, we will look at each table in detail in the next two slides.